Lines and angles in parallel and perpendicular lines. Parallel lines are two lines that do not intersect and are coplanar. So that word coplanar means they're on the same plane. An example of parallel lines on our diagram are right here. Line AF and BG. When we talk about skew lines, we're talking about two lines that do not intersect and are not coplanar. So these are lines that are not going to intersect, but they are not on the same plane. So if we have AB along that top plane and line DE along the bottom plane, they're never going to intersect, but they are on different planes. Perpendicular lines are two lines that intersect to form a right angle. So here we have line BC and line BG that intersect to form that right angle. And usually in a three-dimensional figure like this, if you see a right angle in one place, it's actually going to be a right angle at all of those intersections. Oblique lines are two lines that intersect but do not form a right angle. So if we use line IJ and line AF, they intersect, but because IJ is at an angle when it meets AF that is not 90 degrees, they are not perpendicular, and they're just called oblique. Lastly, coincident lines are two lines that intersect at all points. If we were to talk about the line that goes through JH and also the line that goes through CH, we actually end up highlighting the exact same line. So line CJ and line JH, that would actually be the exact same line. Now, parallel planes are two planes that do not intersect. So when we want to talk about those planes, in this diagram specifically, think about it like a room. The ceiling and the floor, if it's architecturally sound, should never intersect each other. If they extend forever, they're never going to find a point where they meet. So those are called parallel planes. Now here are some theorems about parallel and perpendicular lines. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So here we have line G and line H, and they intersect to form a linear pair, which means they're adjacent and their non-common side makes a straight line. So these two angles are supplementary. So how do you get supplementary angles that are also congruent? They have to each equal 90 degrees, which makes G and H perpendicular lines by definition. And remember, this upside down T is a symbol for perpendicular. So we say that line G is perpendicular to line H. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So if we have two adjacent angles and the non-common sides are perpendicular, meaning they intersect to form a right angle, then those two angles have to be complementary, because by definition, complementary means that the two angles will add up to 90 degrees. If two lines are perpendicular, then they intersect to form four right angles. So by definition, if we have perpendicular lines, they intersect to form one right angle. But we know that these two would be a linear pair and supplementary, so this has to also be 90. And then these two would be a linear pair supplementary, so that has to be 90. And following that same logic, these two have to be supplementary, so this would also have to be 90. So technically, perpendicular lines form four right angles. If two lines are parallel to the same line, then they're parallel to each other. So if we say that line X is parallel to line Y, and line Y is parallel to line Z, then using the transitive property, line X is parallel to line Z. Because if X and Y never intersect, and Y and Z never intersect, then X and Z should never intersect. And those double L's, that is the symbol for parallel. Next, we want to talk about what happens when you have two lines that intersect with a third line. So a transversal is a line that intersects two or more coplanar lines at different points. So now we're talking about the same plane. We have these two black lines, And this green line intersects them at two different points. So we would call this green line the transversal. Next, we're going to talk about what happens with the special angles when we have a transversal intersecting at least two lines. First, we have a term called corresponding angles, and these are angles that occupy the same position. Now, in terms of talking about position, I want you to think about it this way. If you were to make a circle around each intersection, then it's a little easier to identify their position. Angle 1 is in the top left side of the circle. So here, angle 5 is in the top left side. So we would say that angle 1 and angle 5 are corresponding angles. Angle 2 is in the top right side. Angle 6 is in the top right side. So angle 2 and angle 6 are corresponding angles. 3, bottom right, 7, bottom right. So angle 3 and angle 7. 4 is in the bottom left, and 8 is in the bottom left. So angle 4 and angle 8 are corresponding angles. Next, let's talk about alternate exterior angles. These are two angles that lie outside the two lines on opposite sides of the transversal. So let's take this into account. First, let's draw our circles again, just to identify which ones we're talking about. And then here, we want to specifically talk about these two lines. So if we highlight those lines, and we only want to talk about the ones that are outside of them. So we're talking about the exterior angles. So we want the ones outside of those two red lines. So we don't care about these four angles right now. We're just focused on 1 and 2, 8 and 7, the ones outside. Now that word alternate means opposite sides of this transversal. So they need to be on opposite sides of that green line. In our ruling from before, you have to take one angle from each circle to make a pair. So 1 is on the left side, 7 is on the right side of the transversal. They're in opposite circles, and they're both outside of the red lines. So angle 1 and angle 7 are alternate exterior angles. Likewise, angle 2 and angle 8 are alternate exterior angles. So use the words in the term to help you define them. Exterior, the ones outside. And then alternate, they're on opposite sides of the transversal. And then lastly, remember, one angle from each circle to make a pair. Alternate interior angles are two angles that lie inside the two lines on opposite sides of the transversal. So it's very similar to the alternate exterior angles, except this time we're talking about alternate interior. So let's go ahead and start by drawing our two circles, and then we're going to highlight those two lines again. So remember, we're always highlighting the ones that are not the transversal. Then from here, we want to talk about the ones that are in the interior of our two lines. So not the ones that are outside, we just want to focus on the ones that are in between the two lines. And then we need to talk about that word alternate, which again means opposite sides of the transversal. So we want one angle from the left side and one angle from the right side. And lastly, remember, one angle from each circle. So angle 4 and angle 6 are alternate interior angles. And then we have angle 3 and angle 5. So remember to use your words again. Interior, inside the two lines. Alternate, opposite sides of the transversal. One angle from each circle to make a pair. Next, we have consecutive interior angles. And these are angles, two angles that lie between the two lines on the same side of the transversal. So again, just out of habit, we'll start off with our two circles, and we are going to highlight the lines again because we want to just focus on the interior angles. So again, we'll eliminate the exterior ones and just focus on the ones interior. Now, we've taken care of that part. The consecutive part. Consecutive means in a row. And so remember, If we still have to take one angle from each circle, we've already done the ones on the opposite side of the transversal. Now we want to go with the ones on the same side of the transversal. So we have angle 4 and angle 5, and then the other pair is going to be angle 3 and angle 6. So we're still talking about interior, but this time we're using the word consecutive to tell us they're on the same side or in a row. Now we're just going to go through a series of example problems working through all of the vocabulary terms we learned today. So first, I want you to think of each segment as part of a line. So each segment on the diagram is part of a line that will extend, and you want to complete the statement with parallel, skew, or perpendicular. So I want you to try these and then check back with me when you're finished. Hopefully you got parallel, perpendicular, perpendicular, and skew. If you got any of these wrong, make sure you go back to the vocabulary we defined at the very beginning of this lesson and make sure to study those so you know each term very well. In this next example, again, think of each segment as part of a line and you want to answer each of these questions. Go ahead and try it and check back with me when you're finished. For the first one, you could have had line LP or line QR is parallel to line MN. For the second one, line QR, line RS, line LP, and line PN are perpendicular to line PR. For the third one, line LM, LP, or line QR is skewed to line SN. And for the last one, plane MNS is parallel to plane RPL. In this next set, you want to look at the diagram with the angles and complete each statement with either corresponding alternate interior, alternate exterior, or consecutive interior angles based on the relationship of each pair of angles. Go ahead and try this and check back with me when you're finished. Hopefully you got the first one corresponding, second one alternate exterior, third one consecutive interior, fourth one alternate interior, fifth one corresponding, and the sixth one alternate interior. If you got any of these wrong, make sure you go back to the 4 different sets of notes we wrote regarding these relationships of angle pairs and make sure you double check and you're certain of what each one means. Now, we've talked about proofs before and we did an introduction to them. So now, based off of the theorems and ideas we talked about today, I want you to go ahead and try this proof. So go ahead and pause and then copy down what's here, and I want you to try to fill in the blanks with the word bank below, and then you can check back with me when you're finished to see how you did. So for number 1, how do we know that ray CD is perpendicular to ray CE? Because that's what's given to us in the prompt. Then we want to know, how do we know that angle DCE is a right angle? So DCE, how do we know it's a right angle? Now be careful. Just because it's marked in the diagram, I don't want you to say that it's given. The only facts we can say are given are what's written up here in the original prompt. So the way that we know that DCE is a right angle is because that's the definition of perpendicular lines. When we say that these are perpendicular, they intersect to form that right angle. Then, how can we use the definition of a right angle to tell us something? The definition of a right angle is that the measure of that angle equals 90 degrees. Now, when you look at line 3 to line 4, it seems like we might want to use the transitive or substitution because measure of angle DCE and measure of angle DCE is still there, but that 90 changes to a measure of angle 1 plus a measure of angle 2. However, in order to use transitive or substitution, we would need to have another equation up here that relates these two to each other. And since we don't have that, we can't use those properties. And they're actually not even available down here. So we need to think of other options. The measure of angle DCE, the measure of the big angle, is equal to the measure of angle 1 plus the measure of angle 2. So if you actually remember back to Unit 1 when we talked about how a big angle the measure of that can be split into the two smaller ones inside added together. That's the angle addition postulate. Then, from the measure of angle DCE equals measure of angle 1 plus measure of angle 2, we want to somehow use substitution. So the only thing we could actually substitute here is substitute that 90 here in place of measure of angle DCE. So we're going to say that 90 equals the measure of angle 1 plus the measure of angle 2. Now we can say that angle 1 and angle 2 are complementary because that's the definition of complementary angles, that their measures add up to 90 degrees. I'm hoping you got this right. I know that step 4 was a little tricky, but based on the word bank you were given, hopefully you were able to figure it out. That's it for today. I'll see you in class.